This one we're asked to expand this logarithm. Okay, and there's a couple different steps that we need to deal with here, and we can kind of take them one at a time. The first step here is that I have something on top and divided by something else. Okay, and this is going to be a log base 5. When we expand it, it will also remain, I guess I should say, a log base 5 as well. So let's kind of look at what the rule is that applies here first. This one states that if it's division, if we have an x divided by a y, we're going to rewrite it or expand it in such a way that it's log base a x minus log base a of y. Okay, and let's kind of look at an example here. If I have, this is a log base 9, n divided by 4, and that I can rewrite as, these are both, notice how both of these are log base 9. Log base 9n minus log base 9 of 4. Okay, either these are equivalent values. This one is in expanded form and this one is in what we call condensed form. So now let's use that principle and apply it up here. So I've got a b squared on top and a c cubed on bottom. So when I rewrite it, it's going to still be log base 5. It'll be b squared minus log base 5 c cubed. Okay, and this is essentially the same thing that we did here. Notice how I did not change any of their exponents. We're going to do that in just a moment. But again, the division sign here means that we're going to subtract. Okay, so now that we do that, now we have to worry about these exponents here. And this is still somewhat condensed. It can be expanded a little bit further, so we're going to do that now. Here's the rule that applies to that one. It says that if it's a log base x, a to the b, this b we can take and we can move that all the way out in front. Okay, and it will become b times log base x of a. So let's look at an example there. And I give you one that is a natural log because the rules still apply for both normal logarithms, natural logarithms, log base 10, any of those, the rules still apply. So I've got my logarithm here, it's natural log of p cubed. I take this exponent here and I will move it way out in front. And then if I want to rewrite it, it will be this, 3 times natural log of p. These two are equivalent. This one is considered the expanded form. So now I need to apply that up here. I've got this one, and let's just focus on the left-hand side just for a moment. I have log base 5 b squared. So that's squared here. We're going to take that and we're going to place it way out here in front. And then same thing here with this c cubed. This exponent here, that 3, is going to go way out in front as well. So if I rewrite these, it will look like this. I've got 2. Notice how my 2's out in front. I got that right here from this exponent. I moved it out in front. 2 log base 5 of b minus, and it remains minus. That's because of our division sign up here. 3, and that 3 came from right here, this exponent here. 3 log base 5 of c. Now let's look at one that is a natural logarithm. Here's our natural logarithm, and this one is going to follow the exact same rules. In fact, I kept all the variables the same, b squared c cubed. So this division here means that we're going to subtract. I'll do that first. Natural log b squared minus natural log c cubed. And we do the same thing where we move these guys way out in front here. So we're going to do that now. Moved it out in front. This is 2 natural log of b minus 3 natural log of c. Okay, so even if it's a natural logarithm or if it is a log base 5 or log base 10, any of these rules still apply. But right here that I have circled in red are the most expanded form. This is, if we start with this one, we remain, notice how this one started with log base 5, we keep that log base 5. This is a different problem. We started with a natural log and we ended with a natural log.